So this is just to show you a little bit about SQL. I will give you time to work with this on Tuesday, and I'm not expecting it to stick at this point, so don't panic. So what I'm going to do, I'm actually going to close all this stuff. I have some data in some of these because I was showing you that. All right, so I'm going to click on a new query. Okay, and it gives me this query window. We've looked at this before. And I'm actually going to use, I think most of you have this if you want to follow along, but you don't have to. Community Assist. I'm going to use it for my queries because there's data in it. I haven't entered as much data as you guys have for this. SQL is a language that is in every relational database. All right, so SQL is a language that is used in Oracle. It's a language that is used in MySQL. It's a language that is used in Postgres, and it's used in Microsoft SQL Server. It's a common language. One of the things that the original developers of the relational model wanted was that there would be one language which would do everything within the database, and SQL became that language. I say SQL, but some pundits, if you go online, will say it should always be said SQL. SQL is a reserved, it's a patented term, actually. So, and SQL has been around since the 1970s. It's not a new language. You don't go out and buy it, though. I mean, it's not like, it used to be you could go out and buy a package like C++, you know, Visual Studio or something. It always comes with a relational database. It's always part of it. Everything you can do in the menus, everything you can do in the graphic things, you can do with SQL, right? Every single thing. And in fact, a lot of things that aren't in there, aren't in the GUI. What else do I want to say about SQL? It's one of the easier languages, I think. It can get complicated, but it's fairly easy because it's not case sensitive. Even in Linux, it's not case sensitive. It is what they call a fourth generation language. Does that mean anything to anybody? Not that this is important, but it's always fun to go through. What would be a first generation language, computer language? There's only one first generation language. What? Assembly? Assembly I would consider second generation. Before assembly, there is machine language, right? The zeros and ones, the switches off and on. Originally, they actually went in and rewired the switches when they wanted to do a different program. Assembly is the second. And assembly is basically giving names to those switches being off and on so that you don't have to remember zeros and ones. But it's still really low level, meaning that everything is hard. If you want to print something on the screen, you have to go to the processor, you have to go to the memory address, you have to fetch the symbol there, you have to put it into a queue, you have to process it, you have to put it up into the register to be displayed. I mean, everything takes forever because you're at the level of the machine. Computers are really awkward. They're really stupid, except that they can do things at lightning speed. And so that makes it seem like it's working better. So second level language, second generation language is assembly. They still use that when they're working on operating systems and drivers and things like that, where they have to get really specific about how memory is managed, you know, and how the processor is accessed. So when you're dealing with hardware, basically they still use assembly. What's a third generation language? And I don't expect you to, you know, I'm just asking if you have a guess. C. It's literally almost everything you think of as a programming language. Python, C, C++, even COBOL and Fortran. And the thing about those languages is that they are one command Like in a language, you might have, say, print, like in Python, print, and then in parentheses, you put what you want to print. That word print is a whole batch of instructions in assembly language, right? So every command is a whole pile of assembly commands, machine level commands that you don't have to do because they've summed them up for you into one thing that says print. They're procedural in that they're still step by step. You're working through what you have to do step by step in the orders that you need to do it, right? Things like that. The third level, they're languages that are meant to be halfway between humans and computers. So, like computers don't understand Python. They don't understand C#. They only understand machine language. So C# or C++ or all of that, they're basically meant to be more understandable to humans, but they're logically consistent in a way that can be interpreted into machine language for machines, right? So languages are compiled or interpreted so that back into machine language. That's all that the machine understands as machine language. SQL is a fourth generation language because you don't have to tell it step by step what to do. You just tell it what you want to do. You don't have to tell it how to do it. So like I can say use Community Assist. I don't have to tell it how to make the switch. I just can do that and execute. Notice a little execute sign there. Use it. Don't use the little triangle. It'll go into a debug mode if you use the triangle. When I click that, it changes. Notice this little thing now says Community Assist. It said Cafe before. And I'm just going to show you a very few commands because if you're going to work with databases, you really need to know a little bit of SQL. And actually, ultimately, you want to know a lot of SQL. As I said, it's sort of the language of relational databases. It is, the other thing I'll say just in general, before I give you the few specific commands, it is pretty much the same no matter what product you're using. Like if you're using Oracle, the commands I'm going to show you would be pretty much identical on Oracle. I would say it's about 85 to 90% the same on any platform because there is an ANSI, standard for it. The trouble is that it's that 10, 15%. It's different, can drive you crazy. If you implement the ANSI standard, you're free to add things to it. So every product adds their own stuff to the SQL. And also there are differences in how they define data types. There are enough differences to make it a little bit of a pain, but it's still, if you learn it on one platform, you're pretty quick. You can be pretty quick to adapt it on another. So I'm going to show you the simplest statement. I'm going to just do select star from person. All right. So select is a command. I like Visual Studio because it's color coded. Just as a style thing, normally you capitalize all of the letters in a reserved word. I'm just sloppy. Asterisk is a wild card, means all the columns. From is a keyword, and what always follows the from is the name of the table. So if I run this, and in SQL Server you can highlight it and it will run only that command. So it gives me all of the stuff in the person table. So it gives me the person key, the person last name, the person first name, the person email, the password, which in this case is hashed, the entry date, etc. Does that make sense? Okay, that's not hard looking at it. So I'm going to do select, instead of star, I'm going to do person, last name. Again, it's not case sensitive, which is good for me. Person, first name, and person email. And then I'm going to say from person. they'll be red underlined until I say from person, because it needs to know what table they're from. So you can select your fields. You don't have to show everything, and you don't have to show them in the order that they are. So like if I wanted to do this as first name, and this is last name, you can do that. You can put them in whatever order you want. And just see the fields that you want. Does that make sense? I don't know if this table has any good linking tables, but I might go back and show you how to do a linking thing in the cafe in a moment. So this is the basic select statement. There's a couple of other things you can do with it that I'll show you now. We'll build on these later. We'll make other ones later. But one of the things I can do is I can sort it. Order by person last name. So if I run just that one, now notice it's A, B, you know, it's in alphabetical order by last name. If I wanted to reverse that, I'm just going to copy this. I could just say, put after this, put DESC for descending, and it'll do it in reverse order. Notice now they're start with Z and go down. A couple of other things I'll say. Again, I'm real sloppy because this is SQL Server. In other environments like Oracle or when we do MySQL, you need semicolons at the end of these. You don't need them in the SQL Server environment, but you do in almost every other environment. Questions on those? I mean, that's the basic select statement. You can always look and see what's in a table. In fact, a lot of times, if I don't remember what's in a table, I'll just do a real quick thing like that just to see what the data is like. Okay, let's look at a simple join. And if we look at the tables and community assist, so let's look at employee. So I'm going to do select star from employee, just so we can see what the raw table employee looks like. So notice there's an employee key and there's a person key, right? And I also have a linking table. I'll just show you real quickly. Select star from employee position. And it's a traditional linking table. Basically, it's just got two keys, rows of keys here. It's not very readable for a human. So what I'll do is I'll show you a couple of joins, how to do some simple joins. Because part of what you want to do, we've split the tables up for the computer, right? Creating sets. But for the humans, you're going to want to make queries that bring it back together in a way that makes sense. So let's kind of build on the employee. So, and then we'll get to employee position too. So the first thing you might want to do if you're looking at this is you really might want to know what the person's name is. So we can bring the person name in here by joining the person table and the employee table. And I'm going to do that. Oops, my order by got, okay. And again, these in the other environments, each one of these would have a semicolon. In SQL Server, it just ignores the semicolon. All right, so I'm going to do select person last name. I don't know why I tend to do last name first. Person first name, and these are columns, right? These are columns that are in the person table. And then we'll add we'll do the employee hire date. I'm going to break the line just to keep it in here. Employee annual salary. I could show you how to format that, but I won't. Notice a couple of things about this. One, you can break the line wherever you want, right? I can just break it up. It's comma here. Notice there's a comma after every column name except the last one. So I'm going to do from person here, because the first two tables, the first two columns are from the person table. When I do that, notice the red lines go away from there. Then I'm going to do inner, can't type, inner join, and we're going to inner join it with employee. So we're going to join two tables. We're going to join person and employee. I'm only going to show you inner joins tonight, but there are other kinds of joins. And then I'm going to, we have to tell how these two tables relate. So the next one is on, and I'm going to say on person dot person key is equal to employee dot employee key. Person key, you're right. My brain is gone. So basically, if you think about the relationship that we made, this is primary key to foreign key, right? You're telling how the tables relate to each other. I've never really understood why it can't pick that up automatically, but it doesn't. So we're selecting two fields from the person table, two fields from the employee table. You just list them. Doesn't matter what table they come from. We're going to do from person, so you just choose one of the two tables, right? Inner join employee. So we're going to join it with the employee table. And we need to know how they relate. So the person key in the person table is the foreign key in the employee. So person key, employee dot person key. So if I run that, notice now instead of, and I could have put the employee key in here too. Right now I see the names of the people and their salaries. So I've got, it's a little bit better. Than it was. A little bit more readable, right? And we've got information from two tables. Does that make sense? These take a little while to get a hang. As I said, I don't expect you to go away feeling confident you can now do these on the fly, but you can practice them, and we will practice them Tuesday. So I'm going to do one more join just to show you can do that. So remember in position, well, we didn't look at position, but let's do a real quick select from position. So position is a list of positions, right? Employee position is a linking table that links employees to positions. And the reason I did a linking table is at least one of these people has multiple positions. Right? They have many positions. So I'm going to do this same. I'm actually going to copy this, but I'm going to add one more thing to it. And I'm going to post all this on the blog, and I'll try to comment it a little. I'll show you how to comment here in a moment, too. So I'm going to add a field here, position name. And that's from a third table. So all I have to do is another inner join, position, on position dot position key. Oh, actually, I have to join another one before that. because I have to include the linking table, so it's actually going to be more complicated. I'm going to do employee position. On employee position, employee key equals employee dot employee key. We're kind of, do I have a diagram here? All right. Well, I was going to draw the picture. If you draw the map, you can see how they relate. And if you want, I will, but I have to change ownership. And I'm going to do one last inner join to position. Okay. On position dot position key equals employee, or not employee, yeah, employee position. Dot position key. All right, so we have we're going from person to employee, right? That's related. Then there's a linking table, which is employee position, which is between employee and position. So I have to go through it. So I go from employee to employee position, and they're linked by the employee key. And then I go from there to position, and the position key from position is in employee position key. Does that make sense? Let me real quickly. I'm going to go into properties. Going to go to files. I'm going to change the owner to SA. I'm going to do OK. I'm going to make a diagram. Although there are some extra tables in here. Add. Okay, let's ignore that. So, where's employee? So employee here has a link. This is person up here. We're going from person to employee. Then we're going to, boy, those are way down there. We're going to employee position and into position. So we're just kind of walking that path. Person to employee, down to employee position, down to position. That's basically what that query is doing. It's just walking that path. And, you know, it's complicated, but when I run all of this, and as I said, I don't necessarily expect this to stick right now, I can see the name of the person, first and last name, their hire date, their annual salary, and their position name. So it's starting to get to something that's readable. Admittedly, it's a pain to write that query, but you could save it as a view and never have to write it again. You could just call it view. Does that make sense for joins, sort of? It's a little complicated, and it takes some getting used to. The join is always one table to, you do from one of the tables. You do a join with a table. You show how those tables relate. And you can keep doing that for as long as you have to. Then we're joining to another table, and we're telling how those two tables relate. And then we're joining to another table and telling how those two tables relate. Primary key, foreign key, pretty much each time. There are lots of ways this can go wrong. Mostly if you get the wrong fields in here. But, all right. I don't think anything in your assignment is quite that bad, although I asked in the assignment for this part just a few questions to answer, some simple selects and some, I think, simple joins. There might be a couple of joins that are a little harder. The other things I want to show you really quickly, and then I want to show you how to comment once. So I'm just going to comment. So comment is dash dash inside of here. So I'm going to say this is a 4-table join. And I might give more comments as we go on. I want to show you how to insert a record. We talked about this a little bit, and then a little bit about how to update and delete. The syntax on these is really simple. They can be a little complicated, but I'll just show it. Let's say I want to insert a new person. Insert into, except I'm commenting. I'll just say insert, and then I'll do it down here. So over here under tables, there's person. I'm going to cheat, and I'm going to show you the cheat. I'm going to grab the columns folder, and I'm going to drag it up here. Gives me all the columns. Because they're auto numbers, I can't enter person key. That's going to automatically, I'm just going to break these. I'm not going to do person password. And I'm not going to do person password seed. Those involve other things, but I'm just going to list the fields. So these are the fields I'm going to insert into. And one of the things about these is that you have to, anything that's required, anything you made not null, you have to insert into. And then I'm just going to do values. And I'm just going to do, anybody have a good name? Somebody to insert. I think I've already got Homer Simpson in here. Let's see.
Axl Rose.
Okay, Axl Rose. So last name is Rose, right? Is that his actual name?
It's his legal name. I don't know if it's the name he was born to.
All right, so person email, I'm just going to do arose at Gmail. Notice I'm using single quotes. For the date, I'm going to actually I'll show you a quick, there should be a comma there. Get date is a function that will return the current date. So if I insert this, it says one row affected. And if I do a select, from person at the very end of it, I can see that there's an Axl Rose. And I didn't do the password, and I didn't do, but it did do the entry date, right? Did today. I realized I forgot to show you any where clauses on this select, so I'll do that in a minute. Now, if I wanted to insert into, let's do just into contact. So contact is basically their phone numbers. So let's just do a home phone. So I'm looking for contact. There it is. I'm going to drag the columns here. That's nice if you don't want to type them. Drag the column folder in. So we want values again. The contact number is just a phone number. Contact type key, I'm just going to do one. It's a foreign key. and one is home phone number. I just know that. You could go look it up in the table. I also need the name of, so Axl Rose is number 130 for a person key. So I'm going to do 130. It has the same problems that if you're, and I can show you some things around it, but I won't right now. This has to be a real foreign key. This has to be a real foreign key. Right? So, and it doesn't tell you what are foreign keys. You kind of just have to know that. So I'm going to insert this. And now if I look, it will show me. So I'm going to do select star from contact. And I'll show you, if you want to limit this, you can do where person key equals 130. And it will just return that one row. So you can use a where clause to limit the number of rows that you're returning. And we can go into that a lot more. I'm not sure that tonight. There are lots of criteria you can use, right? Just where something equals something, where a date is equal to something. You can do greater than, less than. There's lots of different things you can do in there. Okay, so that's inserting. Does that make sense? Inserting here isn't hard. In some ways, I think writing the code for this is actually easier than doing it in the forms, like you guys were doing it. You can also enter multiple values. I'm not going to right now, but you could do a comma. And I could do another number. I'm just going to copy this. Let's say this is 10. And maybe this is type 2, which is a work phone. So you can do multiple values in one insert as long as it's the same table. Right, like that. I'm not going to run it right now because I already ran it. If I had to run it, I could. Okay. That's insert. I want to show you a real quick update and then a delete, and then we'll call it good for the night. And as I said, you can finish your data. There is a assignment for this, but I'm assuming that mostly it'll be Tuesday, and I can review this stuff again on Tuesday. So I want to, this is dangerous, by the way. Insert isn't too dangerous. It could get garbage in there, but it's still not super dangerous. Update is dangerous. I'm going to, before I do update, so I'm going to show you a little key. I'm going to begin a tran, not a tan. It's interesting. It's a keyword too. Tran. That's a transaction. I'm manually beginning a transaction. It's a safety valve. There's no undo in SQL Server or any database unless you are manually beginning a transaction. The bad part about this is if I had a lot of other people coming into the database, I've frozen this table. Does that make sense? I'm frozen anything I'm doing. And you don't really want to do that. But I'm doing it because I want to show you update. I'm going to say update person. And I'm going to say set last name, or person last name. And I'm going to say equals Smith. What do you think would happen if I run that? Everybody's last name is Smith. So I'm going to do a quick person. Notice it says 130 rows affected. Select star from person. This is the kind of mistake that if I hadn't done the begin tran could get you fired. Imagine instead of 130 people, you had 300,000 people. They're all named Smith now. It's worse than the last matrix. You have to see it to get this. So one of the things about begin tran is I do have an undo. I can do rollback tran. Now, if you haven't done begin tran, and you actually have to run it, not just write it, then you're screwed. So I'm going to do execute. And now if I select start from person, it has gone back to the way it was. So you can roll it back if you make a mistake. Updates are dangerous. But let's, so notice, let's do an update that's done the way you should do it. And I will use the tran just for safety. And I'm going to, so I want to run it. Did I run it? Okay. So then I'm going to update person. And I think I'm going to set first name, and it's person first name, equals Jason, where, and this is the important part, where person key equals 1. Right, so I'm limiting it by saying where person key equals 1. So I can go in here, I can look, it says 1 row affected, that's a good thing. So I'm going to do a quick select. J is now Jason. Okay. And if that's good, I can stay, instead of roll back, and can say commit with 2 M's. Commit tran, and it will write it to, it'll actually write it so that it'll be permanently in the database. Once you commit or roll back, there's no, that's it for the transaction. It's done. Right? So updating is for changing existing data. Inserts is for adding new data. Updates is for changing existing data. We'll talk about it a little bit when we go into security. This is a permission you should probably give no one. There are ways to do this with like a stored procedure or something where you can couch it in another structure so that it's impossible to do without providing the proper key. I might show you a little bit of that at one point. So that's updates. And then the very last thing I'll show you is a delete. And deletes are a little bit dangerous. They're not as dangerous as updates generally, but they can be. If I just go into delete from contact, and I'm just going to say where, although I'll do another one first, where person key equals 130. Before I do that, and you can put these in a tran too, it's not a bad idea. I'm going to try to delete from person where person key (130). All right, well, if I try to do the first one, what do you think will happen? It says that I can't delete it because it has child rows, right? It has a row in contact related to it. So you cannot delete it if it has related children. If I come here and delete the child, that goes away just fine, says Ryan row affected. And now when the child is gone, I can delete the parent. The reason it's that way is so that you don't leave fragments around. So you don't delete the parent and then there are related records that are left hanging because they're, no longer have a parent. It sounds really cruel, deleting children, deleting parents. But you have to delete all the children before you can delete the parent. It also sounds like a Game of Thrones a little.
Makes sense.
It makes sense,
You don't
yeah.
wanna leave all those children out there without parents.
Yes, I know, make them all orphan. And that's actually what they call a record that doesn't have a parent anymore. They call it an orphan record. By default, you can't leave orphan records. There are ways to make it happen, but you don't really want it to happen. I think that's all I'm going to talk about for the SQL today. I mean, there's a world of stuff more to cover, but this is just the basics, and it's basic. All you really need to do the SQL assignment. But again, don't panic about it. We can do it on. I'm going to give you time on Tuesday and go over some of this again. There's also a video which I is still recording right now that you can look at, and I will post this text on the blog. And I think we're about done because we're about out of time. The other thing is, have a great weekend. I need it. I need to rest. So let me post all of this stuff. So first of all, I'm going to stop the video so it doesn't have too long of a trail.